All right, here we go. So we've got these two blocks. Mass number one, this guy is 4 kilograms. And we got this guy on the bottom here, which is 5 kilograms. They call them MT and MB. This is the mass of the block on the top, and this is the mass of the block on the bottom. All right, now it says to cause the top block to slip on the bottom one while the bottom one is held fixed, a horizontal force of at least 12 newtons has to be applied to the top block. So that's indirectly a way of telling you the maximum force of static friction, right? It's telling you that if we got the mass on top, and you apply a force applied, of 12 newtons, that's going to just barely overcome our force of static friction maximum, right? And so, if this dude, the mass on top was 4 kilograms, right? That means that my force of gravity on that guy, on the block on top, is going to be negative 39.2 newtons. That means that my normal force on block 2 is positive 39.2 newtons. So I can find my coefficient of friction by taking my force of static friction maximum and dividing it by the normal force, right? If you rearrange the maximum friction equation. So that gives you 12 over 39.2. And you discover that that coefficient of friction is 0.306. So that's the coefficient of friction between the two blocks. All right. Now, it says the assembly of blocks is now placed on a horizontal frictionless table as shown. Find the magnitude of, you know what, I think I'm remembering that we didn't even need that coefficient of friction. Yeah, you don't even need that. I did extra work. There you go, you learned for free. All right, so question A says, what's the maximum horizontal force F that can be applied to the lower block so that the blocks will move together? So here's the deal. That force of static friction is actually, sorry, I lost my train of thought there for a minute. That force of static friction is actually going to be, in the situation described here in the problem, that's going to be what makes the block accelerate. Check it out. If I pull the bottom block with some force, okay, we'll call that F, then what's happening is, for the block on the top, so here's my mass on the top now, right? Mass on the top, 4 kilograms. The idea is I don't want it to slide across the bottom block, right? So the most force that I can possibly apply to prevent the blocks from sliding is 12 newtons, right? Because that was my maximum static friction, right? Okay, and so that would make the top block accelerate at 3 meters per second squared, right? Just 12 divided by 4 kilograms, right? So now the question is, how much force do we need to apply to the lower block to get that same acceleration? Well, let's see. So here's my lower block. Now, it's important to note that the surface here is frictionless, right? So the question is, how much force can I apply here? So I guess there's a couple ways of doing this. Is the reason I'm hesitating a little bit. So option one is to just say, well, this force is moving a total of 9 kilograms, right? On a frictionless surface, and if my acceleration is 3 meters per second squared, then that force has to be, 9 times 3, or 27 newtons. Net force equals mass times acceleration. So that force is moving 9 kilograms worth of mass at an acceleration of 3 meters a second squared, so 27 newtons, okay? Now, the other way you can do it, and this is harder, but it's worth understanding, is this, that look, so let's just look at the bottom block. So here's the mass of the bottom block, it's 5 kilograms, right? We know that we want this thing to accelerate at 3 meters per second squared, and the question is, how much force can we put on it? Well, look, this force of static friction on the top block, that's actually the force of the bottom block pushing the top block forward, right? Well, Newton's third law tells us that there's a reaction, and that reaction would be the force in the top block pushing the bottom block backwards. So here's the force in the top block pushing backwards with a force of 12 newtons, right? Okay. So now, if the acceleration of this block is 3, then my net force is going to be mass of the bottom block times the acceleration of the bottom block. So 5 times 3 gives you 15 newtons. So now the question is, what does this force have to be here? This is the worst F in history. What does that force have to be, knowing that the top block is pushing back with 12 newtons to make the net force 15 newtons? Well, what number minus 12 is 15? Oh, 27 newtons. All right, so there's that same answer again, just achieved a different way. All right, there we go.